In the previous video, I have explained you these things. Let us start the next topic, control flow statements translation. The translation of control flow statements such as if else statements, while statements, switch case statements are translated into three address code using three things: Boolean expressions, conditional and unconditional go to statements. That means whatever the control flow statement given, we will write the corresponding three address code using Boolean expressions, conditional, unconditional go to statements. Usually, the Boolean expressions are used to do the following. First one, to alter the flow of control from one place to another place. For example, in if statement, we will have the condition. If that condition is true, then we are going to transfer the control to the if block. Otherwise, we are going to transfer the control to the else block. Second, to compute logical value means we will combine two or more expressions into a single logical value. Next, what is Boolean expression? A Boolean expression is an expression that gives either true or false values always. And sometimes Boolean expressions are composed of the Boolean operators like ampersand symbol, or symbol, not symbol. So we can combine relational expressions, Boolean variables by using the above Boolean operators. Next, relational expressions are of the form E1, relational operator E2, where E1 is arithmetic expression, E2 is also same, and the relational operator can be any one of the following: less than, greater than, less than, equal to, and so on. So this relational expression, when evaluated, it gives true or false values. That means Boolean expressions can be created by using relational expressions. Short circuit code. In short circuit code, the Boolean operators or Boolean expressions are translated into three address code using jump instructions. Means to translate the Boolean expressions, we use simply jump instructions. For example, see here, this is the Boolean expression with the two parts: x is less than 100 and x is greater than 200. So here R is given, so we will evaluate this first one. It is true, then it is going to be executed. Otherwise, we will test the second condition, second expression. If it is true, then this x equal to 0 is going to be executed. That means the code will be like this. We will write the code first for x is less than 100. So if x is less than 100, go to L2. So what is L2 means? Truthfulness statement of the condition. Means when it is true, we have to execute the statement that is placed in L2. Similarly, if this fails, x is less than 100 fails, is false, then we will check the second condition immediately. X is greater than 200, go to again L2, L1 out of the if statement. So in this way, in short circuit code, we write the simplest code to translate a Boolean expression. We take some lengthy expression of if else statement. So here there are actually three expressions, but we take it into two Boolean sub expressions. It is expression 1, it is expression 2, because it is having high priority than AND operator. So we will divide into two parts, B1 and B2. So first evaluate B1. If it is true, then this instruction is going to be executed. Otherwise, the second expression means second sub expression is going to be executed. If it is true, then it is going to be executed. The code will be like this. So if x is less than 100, then go to L2. So L2 is a label line number which contains the instruction x equal to 0. So L2 may refer address. Next, if it is not true, then we have to execute the second condition or second Boolean expression. So we are using the statement go to L3. So in L2 we have written this statement related 3 address code. So here again two sub expressions are there. X is greater than 200 and x is not equal to y. But however, we have to verify these two to evaluate the true condition. Means first evaluate x is greater than 200. If it is true, then we will check the x is not equal to y. If both conditions are true, then only the total expression becomes true and x is 0 is going to be executed. So here if the three address code will be x is greater than 200, go to L4. Means here we are transferring control to the next statement. Next condition belongs to the same Boolean expression. Next, if x is not equal to y, then we are transferring control to L2, true statement or address of true statement here. Next, otherwise means if x is greater than 200 is false, then is transferred to L1. Similarly, second condition false, first one is true but second one is false. In that case also we are transferring control to L1 out of the if statement. So in this way we will translate the given if statement into 3 address code. Next, take the switch statement in this form. So here first of all we have to evaluate the expression into some value, say t, and based on the t value, suppose we will check the t equal to v1, then execute s1. If t equal to v2, then execute s2, and so on. We will continue the process, and the corresponding 3 address code is shown below. So first of all, evaluate expression e and store the result into t. Next, go to test statement. Go to test. So what is test? Core logic of the switch case statement. So in the test label, the address, we are going to check the t value with v1. So if t equal to v1, then go to L1. So this is going to be executed, and thereafter once it is completed, we will exit the switch case, that is using go to statement. Similarly, if t equal to finished, we are going to exit by executing go to next instruction. So next one like this, and if all these conditions becomes false, then the default condition takes place, that is go to ln. It is unconditional go to. So ln represents execute the code for statement sn. So after this we will come out from the loop, that is whose label is next. In this way we will translate the given switch case statement into the 3 address code. Next, take the loop statement. To translate this loop statement also we will use same Boolean expressions, conditional, unconditional, go to statements. So first we will write the code for do body calculation. So here do while loop is a exit control loop. That means first we have to evaluate this, execute this expression, execute this statement. So t1 equal to I plus 8 and I equal to t1. It is the body of the do while loop. So after executing this body, then you have to check the condition. If I is less than or equal to n, this condition is true, then go to the L1 part, execute the body once again. After execution, check the condition again, then go to the body again. So in this way we will translate the loop statements into 3 address code. Next, function call statements translation. We know that function is a function or procedure is a collection of statements, block of statements with some name, and when that function name is called, then the body of the function instructions is going to be executed. And here we will see how procedure calls or function calls are translated into the three address code. For example, add of x1, x2, and so on xn. Here add is a function name with parameter. So it is a function call statement. The three address code for this will be, first we will write all the parameters. Param is a keyword. Param x1, x2, xe, and so on xn. We will write all the parameters list. Followed by call is a word, followed by function name. Here it is add, comma n. N means how many parameters we are passing to this function. That number will be called. Suppose we are passing 2 parameters only, then n will be 2. Similarly, if a function returns a value, then it is translated into the following. For example, similarly as previous one, we will list out the parameters x1, x2, and so on xn. Then call the function using call keyword, and here y equal to appears before call. The reason is it catches the value returned by the add function after, during execution. For example, consider this statement. How to translate this into three address code we will see now. So here there are two things. One is ordinary statement and function call. So for this we can write the three address code first. First translate the first statement, means t1 equal to I into 4 and I equal to t1. Then by using the I value, calculate the parameter value. Suppose t3 or t2 equal to t2 equal to a of t1. So after that use the function corresponding three address code. So this is the first statement, equivalent three address code. After this we have to calculate the parameter value. So parameter value a of y is calculated using I variable that is just computed before. So t1 is equal to I value. For that reason actual function logic, function call logic. So the function call logic will be parameters list. Only one parameter is there, namely t2, and function call keyword function name, comma how many parameters we are passing, only one, that is called by variable t3, and it will be assigned to n. So this is the way to write code for three address code for function call statements. Next, backpatching. The difficult task in the generation of three address code for control flow statements is determining the target address of each go-to statement. So suppose I am using a number of conditions or some n number of repetitions like that. In that case, fixing the go-to target address is something difficult task. For that task, we can use backpatching, which makes easier to derive or determine the target addresses in the go-to statement. That means a key problem when generating these addresses, these three address code for flow of control statements, is that matching a jump instruction with the target address of the jump, means matching a jump instruction with the target address of the jump. That means finding the address of the target address of the jump instruction is the difficult task, something cumbersome. So for that to solve that problem easily, we can use backpatching. In this backpatching process, first series of branching instructions, branching statements with the targets of the jumps left unspecified is generated. That means we will generate the skeleton code. That means write all the code, but the target address of the go-to statement is left blank. That means, see the example. See here. So we have written almost the code, but the target address of go-to is not filled, is left blank. So that is called skeleton code. So first we will write that one. First, a series of branching statements with targets of jumps left unspecified is generated. Thereafter, each statement will be put on a list of go-to statements whose labels will be filled when the proper label can be determined. So when we are in a position to determine what is the target address of a particular go-to statement, then we can fill it accordingly or serially, sequentially. This process is called backpatching. So we call the subsequent filling of blank labels in the three address code. First one, construct the syntax tree. Construct the syntax tree for the given Boolean expression. Next, walk the tree in depth first order. Depth first search order, suppose. Thereafter, compute a true list and false list of Boolean expression at each node of the syntax tree. So here we have to calculate true list and false list at each node. Have to calculate, and after that do the translations accordingly to obtain the uh, target addresses of each go-to statement. To manipulate lists of labels in the three address code generation, we use three functions: make list, merge list, backpatch. So make list of I creates a new list with next line instruction I. So simply it creates a new list. Simply it creates a new list. We'll see what is the use of list, what it contains later. And returns a pointer to the list it has created. Second, merge. So as the name implies, it concatenates the lists pointed by P1 and P2 and returns a pointer to the resulting list. Next, backpatch of P comma I. It inserts I as a target label for each of the statements on the list pointed by P. That means backpatch function inserts inserts I value as the target address in all the lists pointed by P. All the statements of the list pointed by P. We'll go through a simple example. So to represent backpatching process, first you have to write syntax tree. So while writing syntax tree, first we take the expression and divide it into parts. Say this is B1 and this is B2. Suppose B1 and B2. So this expression, Boolean expression B, is split into two parts. So why? Because we know that this is having high priority, split into two parts. So I will take the B as root node and left child will be B1. The next child will be R symbol and next child will be B2. So in this way I will write the syntax tree as shown below. So B is the root node or total Boolean expression and it is split into two parts, B1 and B2. So B1 represents x is less than 100 and B2 represents the remaining part of the Boolean expression. So here, so this part is B2. This part is B2 actually contains two parts, two sub expressions, B1 and B2. Again, we for the namesake we call it as B1 and B2. So the first one is B1, which is nothing but x is greater than 1, and the second Boolean expression x is not equal to y, and these two are combined by the Boolean operator and symbol. Next step is we have to write the skeleton code, three address code. That means we will write the three address code with blank jump instructions. We will write the three address code but the jump instruction means go to instruction target addresses are unspecified as shown below. So first I will convert this first expression b1 into readdress code. So x is less than 100. So I will write here, if x is less than 100, go to blank. We'll fix that later at the end of the backpatching process. And define each statement with some label so that we can refer whenever it is necessary. So the first statement address is 100, second one is 101, means if it is false, then you have to check the next boolean expression, remaining part. So I have to use that label here. Okay. Next, the immediate statement is checking of this one. So this already contains two parts. I have to check the first part and second part as available here. So x is greater than 200 is given, then go to address that is unspecified. Next, otherwise go to some value. Next, immediately now x is not equal to y statement, and 105 go to statement. So up to this the controlling process is completed. What is going to be done is you have to execute the, if it is true, it means if this total boolean expression gives true value while evaluation, then z equal to 0 statement is going to be executed. Otherwise the control is skipped to the next statement after the z equal to 0 statement. So this by this backpatching process we have to calculate the target address of go to statement 1, 2, 3 and so on. So while evaluating this tree, we will use the translation tools called syntax directed translation tools. Here a boolean expression may be a combination of two boolean expressions with or symbol or boolean operator. In this case, how to evaluate the boolean expression result is given here. So here first we have to calculate the true list and false list. So what is true list? So true list denotes the address of the true statement of the condition. True list denotes the address of the true statement for a specific condition. So the true list is equal to true list when b becomes true. When the b becomes true means here r boolean operator is given. So either b1 is true and b2 is r b2 is true, then b becomes true. So that means if b1 true list b1 is true, then we can stop the process and say that the b also true. If it is not that, then we have to evaluate the b2 expression, boolean expression. If it is true, then the b becomes true. That is the meaning of that. Next, when it is false means actually both false, b1 false and b2 false. But actually when b2 is going to be evaluated means when only b1 is false. So if b1 is false, then we are going to evaluate the b2, and b2 is false, then we say that b is also false. So for that reason, in the b's false list we represent only b2 false list, but internally or implicitly it includes b1 false list also. So this is the translation process, and when we are going to evaluate b2 means is given in the backpatch function. So backpatch of b1 false list. So when b1 is false, when b1 boolean expression is false, then only we have to evaluate the expression b2. Evaluate the expression b2. So what is actually here, this represents b2. So what is m dot instruction means, the m is a marker or a temporary node or temporary address that holds the next instruction address. Next instruction address. That means Next instruction is actually B2 Boolean expression, whose starting statement address is maintained by the marker M. That means if B1 is false, then only we have to evaluate the Boolean expression B2. Otherwise, we need not evaluate. Means if B1 is true, then simply take this B as true. Next, what is the meaning of B1 and B2? So sometimes B may contain two sub-expressions B1 and B2. In this case, how to evaluate, we will see. So B dot true list means when B becomes true, means B1 become true as well as B2 become true. B1 become true as well as B2 become true. So in the translation rules, false list denotes the address of the false statement of the condition. We will see that by example. So simply analyze the rules, translation rules here. So B dot trueList is equal to B2 dot trueList. That means actually as a part of this, if B1 is true, then only we are going to evaluate B2. If B1 is false, no need to evaluate B2. That means if B1 is false, automatically B becomes false. No need to check the second condition, B2. So for that reason, we say that only when, but it implicitly includes B1 dot list also. So next, false list. When B becomes false, means there are chances. When B1 is false, B1 Boolean expression B1 is false, then B becomes false. Otherwise, if B2 is false, suppose B1 is true but B2 is false, then we say that B becomes false. This way we write this. Similarly, the backpatch function represents when we are going to evaluate B2 means when B1 is true. When Boolean expression B1 is true, then only we are going to calculate the next instruction which contains the B2. Boolean expression, that is the meaning of this. Next, B implies not B1. That means opposite. So B becomes true when B1 is false. So that equals, see here, B1 dot false list means B dot true list. So B becomes true when B1 becomes false. Similarly, when B becomes false means B1 becomes true. Next, M implies epsilon means here M is a marker that represents the address of the next instruction, but it is a dummy variable or temporary variable. Next step is write the pre-address code with blank jump instructions. Blank jump instructions. So you have to write this. It's already known. So here x is less than 100 is translated into this statement whose address is 100. Similarly, remaining all fixed. So thereafter we have to determine the target address of go-to statements. So for that we have to traverse the tree. We have to traverse the tree in depth first search order and find true list and false list of Boolean expression at each node. See the process. So that means you have to construct the annotated parse tree. So what is annotated parse tree? A parse tree with some sort of decorations is called annotated parse tree. So we know already the construction of syntax tree, and we traverse this. In depth first search fashion, like this. So when I come across this Boolean expression, B1, then I have to find the true list and false list of the Boolean expression B1. So for the namesake, in general purpose, we are calling B dot true list and B dot false list. TL means true list, FL means false list. But it find means true list. So b dot row list at Boolean expression b1 represents the address of the true statement. The address of the true statement. So what is the b1 expression? X is less than 100. See the actual code. So in which location x is less than 100 statement is available? 100. That is the true list of the b1. Next, what is the false list? So when it is false, then which statement is going to be executed? This one. That is available at which address? 101. This will be the false list and this will be the true list. So this will be the true list and this will be the false list for expression b1, that is x less than 100. So we have obtained true list of b dot true list is equal to 100 and b dot false list equal to 101 for the expression b1, that is x less than 100. Similarly, we have to traverse the entire tree in depth for such traverse. So when I come across this operator, Boolean operator, then you have to represent the next instruction address. So simply join one node, that is marker, m means marker, dot I is equal to next instruction address. So we already the current instruction address is 101. So next one will be ultimately 102. So serially it is numbered. It is numbered serially. So we have to fix that, representing that the next instruction will start at 102 address or location. See the actual process. So here we have write this. Next, similarly, traverse this tree. When I come across this node b1, I have to find the true list and false list of this b1. So here b1, what is b1 expression? X is greater than 200. I have to find out the true list. I have to find out the true list for x is greater than 200. So what is true list? True list denotes the address of the true statement of the Boolean expression x is greater than 200. See here, this is the statement. So what is the address of this statement? 102. That will be the true list of the Boolean expression x is greater than 200, and false will be 103. That is written here. So this expression, Boolean expression b1, that means x is greater than 200. True list means the address of the true statement, where exactly this x is greater than 200 is available in the code, means at 102 location, and the false statement is available at the 103 location. Next, traverse the list in the same DFS manner. When I come across this operator, Boolean operator, we have to write a temporary node dot I that equal to the next instruction address. So current instruction is 103, then the next instruction will be 104 usually. That will be written like this. So after that we have to traverse this Boolean expression. Again we have to compute the true list and false list. What is the Boolean expression here? X is not equal to y. So see the code, skeleton code again, and find the where exactly this statement is available truly. So x is not equal to y is available at line, see the code. So x is not equal to y is available at line 104, and false list will be 105 usually. But before fixing that, you have to check the other things also. Okay, so here b2, for b2 expression, the true list will be as declared earlier, 104, 105. There is no problem here actually. But when I get the another Boolean expression doing this traversing, the expression will be b2. So which is actually combination of b1 and b2. Here you have to calculate in some efficient way what is true list of this b2. Okay, so when this becomes true, when this becomes means this boolean expression true uh, means here the operator is and, so b1 should be true and b2 should be true. So b1 should be true 102 and b2 should be true 104. Means if this b1 is false, no need to verify the b2, it becomes false, it comes under false list. So when it is true, then only we will go to the b2 true list. So finally this node b2 true list will hold 104 value, and false list will hold, see here, when it is become false means b2 this node b2 becomes false when b1 is false or b2 is false. So b1 is false means suppose this condition is false. This false means automatically no need to verify this. This automate finally declares the false. B2 becomes false. If it is true, suppose, then we are going to check the B2, and this is false. At this case, this expression becomes false. So for that reason, here the B2 false list will contain two values, 103 and 105, as shown here. So B2 node false list will be 103, 105. Next, traverse the tree to reach the root node. The root node will contain two sub-expressions. Here left side b1 and right side b2. And combined operator is R symbol. So when it is going to be true, when the b expression going to be true means either b1, then no need to check the b2. So b dot true list contains here, b dot true list contains 100 as well as 104. That means when b1 becomes true, then directly straightforward I can declare that b is also true. Similarly, if it is false and we are going to verify the next second condition, it is true that is 104, then also we can directly decide that this is also true. Similarly, false, when it becomes false means this is false, suppose, then we cannot say that directly b is false. This is false, suppose, then we cannot say that this is false. In that case, we are going to verify the b2 also. So if b2 is false, automatically what does it mean? b1 already false. b1 already false. So the false list of b contains the values of the this one, that is 103, 105 as listed below. So finally we obtain the root node true list and false list. So from this we can fill the blank target address of the jump instruction. So when this total expression becomes true means there are two cases, 100 and 104. So at line number 100 and 104 go to addresses are filled with true statement location. So what is actually statement going to be executed when this expression becomes true? Z equal to 0. So Z equal to 0 location address is 106. That is going to be filled at location 100 and 104. So 100 and 104 go to target addresses are filled with 106. Similarly, see the false list. So false list contains 103 and 105. So at go to addresses at line number 103 and 105 are filled by the next instruction of if statement. So what is the next instruction of if statement? 107. So 107 is going to be filled at go to target address at line number 103 and 105. So here it is 103 and here it is 105. These two are filled with 107. Remaining is only one is there, 101. It is actually linking. If the first condition is false, just we are transferring control to verify the second condition. So by this process we can derive the or determine the blank addresses of the go-to statements to generate the 3 letters code. This process is called backpatching. Next chapter. Thank you.